Hello, modern robotics class student. Mm. Today we will start about forward kinematics. Until now, we learned about rigid body motion, especially we learned about screw and twist. So this two concept is a little bit new concept for some student, but uh, in the forward kinematics, we will experience about uh, the convenience of screw theory. So let's start about the forward kinematics. Mm, the screw is, as we learned about, the screw is normalized twist. So the size of screw is always 1 over 0. So uh, the screw multiply the magnitude of velocity will be the twist. The twist have 6 vector form, or it can have twist bracket becomes the SE3 form. So this one is 3 by 3, and this one is 3 by 1. So this one becomes 4 by 4 matrix. So there is 6 vector form and 4 by 4 matrix form. And this omega can be decoupled with the unit rotation axis multiplying theta dot. So this omega hat is same with the screw axis. So when we learn about the screw, there was S hat. So S hat is basically screw axis. Sometimes we write screw axis as omega hat. Sometimes we also simply write omega, but that is a little bit wrong expression. Actually, the twist should be omega with V, and when we describe the screw axis, it should have the hat symbol because it is normalized one. So in the screw expression, there was Q. Q was the distance from the S frame, and there is some position along the S screw axis, some point. So some point can be any point on the screw axis can be Q. So this can be also Q, this one can be also Q, this one also can be Q, because when we cross product with Q, it becomes the same result with when we multiply when we do cross product with the orthogonal vector. So actually, all this Q have the same result with orthogonal vector cross product. And we also learned about H. H is screw pitch. It can be calculated by this equation. So this one is the large S is screw, and screw head is screw axis. And screw axis can be calculated by this equation. And theta dot, this theta dot is same with this one, the size of omega. And the screw pitch can be calculated using this equation. So generally we write screw S is omega V. So when we write twist, and also when we write S, we usually using same omega and same V symbol. So sometimes it can be sometimes it is confusing because it is using same symbol. But we should understand in some case omega is screw, omega V is screw. In some case omega V is twist. So there is typical case about screw. When the omega head, the size of omega equal 1, it usually is level joint. Yeah. And also if h equal 0, that means pure rotation. So in the user robot, there are many levels joint, and sometimes some manipulator having prismatic joint. So usually manipulator is composed with these two joints. So when we deal with the manipulator, we encounter these two cases. For the levels joint, omega size of the omega equal 1 and h usually equal 0 because it have pure rotation. It means there is no pitch. And second case is prismatic joint. So in this case, omega equal 0 and V, the size of V equal 1. So this case is prismatic joint. And in this case, theta dot becomes the speed of the prismatic joint. And in the level case, because h equals 0, V becomes like this. So this one was the basic concept of screw axis. So using this, we can calculate forward kinematics in the novel method. So let's start about product of exponential formula. In the previous knowledge, we usually found forward kinematics used by multiplying the homogeneous transformation matrix. So we calculated the relative transformation from 0 to 1. And then we found the relative transformation, homogeneous transformation from 2, 3. And then we calculate 0, 1, 1, 2, 2, 3, and 2, 4. All these homogeneous transformation matrix is multiplied with post multiplication because this one is relative transformation. So we can calculate the homogeneous transformation from 0 to 4. In this homogeneous transformation, it contains the rotation matrix from 0 to 4. And there is a position vector from 0, 4. So using these two information, we can find forward kinematics. The forward kinematics means when we know the theta 1, theta 2, theta 3, theta 4, and given theta 1, 2, 3, 4, calculate the position of end effector. And the effector and orientation of end effector. Doing this is for kinematics. Therefore, in here we can find the position of end effector. In here we can find orientation of end effector. So the homogeneous transformation matrix itself becomes the forward kinematics. So it was the previous concept. And from now on, let's learn about the screw concept. And that means the product of exponential formula. Firstly, in the zero position, if the all theta 1, theta 2, theta 3 is equal 0, then the homogeneous transformation from 0 to 4 becomes like this. Because the orientation is equal, the rotation matrix becomes diagonal, identity matrix, and the position becomes this x is x. So L1 plus L2 plus L3 becomes x component, and y component becomes 0, z component becomes 0. That is homogeneous transformation in the 0 position. And the last axis, the last joint rotate theta 3. This movement can be analyzed by screw motion. This screw motion becomes, this one is S frame, the original fixed frame, and there is screw axis here. This one becomes level load joint, with H0, and there is omega. Omega is theta 3 hat, theta 3 dot equals theta 3 dot, and this omega becomes screw axis. And from this point to this point becomes Q. So using this equation, we can calculate V. The V was minus omega cross Q. And this can be the minus with the transpose with the position. The minus becomes plus. So Q cross omega. So this using this equation, let's find out, we can find out V. So this Q position vector is calculated based on the S frame. The x-axis is here. So Q is L1 plus L2 and 0, 0. And multiplying omega. Omega is 0, 0, 1 because the screw axis itself omega equal theta 3 dot multiplying omega hat. And this omega hat is 0, 0, 1. Because the rotation axis is equal to the direction of z-axis. So in here, this one, yeah, omega hat equal 1, and the rotation axis, the direction of the rotation axis equal z-axis, like this. So this becomes 1, 0, 0, 1 multiplying theta 3 dot. So using this one becomes omega hat. So this one is simply we write omega equal 001 and multiplying q omega becomes minus L1 L2. So the screw axis with the 6-vector form becomes this one. And also if we express in the SE3 form, it becomes like this. And if we know this information or this information, we can make the forward kinematics using this equation. When it follows this kind of screw axis motion, this motion is based on the S frame. It should multiply pre-multiplication, because this one is kind of absolute transformation. So when all the theta equal 0, there was M homogeneous transformation, and on here we pre-multiplying this exponential formula. So we product exponential formula about theta 3 motion, and this one becomes T homogeneous transformation from 0, 4. This only valid when the theta 1 and theta 2 equal 0. If there is another rotating about theta 2, previously the T04 was this one. And if there is theta 2 motion, we also do the same thing about the screw motion. So this one is base position, and there is Q, and there is omega 2. Omega 2 is also 001, and the V2 can be calculated like this. Using these two things, we can make screw S2. Using this one, we can convert exponential formula, this one. And then we multiply one more time in the pre-multiply here. And when there is motion of theta 2 and theta 3, the T04 becomes like this. And one more time, if there is theta 1 rotation, it becomes like this. So it becomes the product of exponential. Shortly, also AKA, also known as POE formula. So we simply call this one POE formula, product of exponentials formula. So using POE, we can calculate forward kinematics. So in this equation, this M is 0 position when all the theta equal 0. It means the initial position. So in here, we don't need link frame. Just we need 0 axis and end-effector axis. 0 frame and end-effector frame. Only using this information, we can make this M matrix. And when we make this matrix exponential representing, we only need screw axis. The screw axis only contains omega and V. So it is very simple. So we don't know we don't need to know about this kind of matrix calculation. We don't need to know about some position. Only we need is only we need is this one, screw axis. The only need is screw axis information, and this screw axis information can be found from zero frame to some frame. So always the basis is always the fixed frame. So this concept is very, very important. So because of this concept, we can calculate the forward kinematics more easily because of this concept. When we think about the frame, we don't need to think about the relative configuration. We don't need to think about the relative transformation. We always, when we using screw axis, only we need to do is to think about some position difference about zero position. Because the basis is always the same one, it is more easier. So in here, I write down the pros in Korean. So when we make the forward kinematics using POE, we only need zero axis and the last axis. We don't need to the axis about between these two things. So we don't need to know about this. Only we need this one, these two things. And the important thing is the S frame, image zero frame can be any position. Not here, we can define this point as zero position. And we think about this. And it can also true. So it is very, very simpler than before. So let's think about more detail. Before we learned about some example having T04. Let's generalize this POE concept with N joint manipulator. When there is some S frame here, and this one is fixed one, and when there is no rotation, when there is no rotation, the initial position, there is M transformation matrix. And when there is the last joint movement, it becomes like this. And n-1 rotation, there is n-1 rotation, n-1 rotation, it becomes like this. And these things become multiplied this way, and it becomes like this. So if we generalize N joint, it can be written like this. So this M matrix, the special Euclidean group 3, the configuration of B frame relative to S frame in zero position. The zero position means theta 1 to theta n equal 0. And screw axis S from Sn expressed in the fixed
base frame. So this fixed base frame, it can be any point, any frame. So we can think this one, or we can define some other S frame in here. And there is joint variable theta 1 to theta n. So we don't need to some I frame, we don't need to about this one. And also, if I frame is level joint, the omega I is unit vector in the position direction of joint axis. Yeah. So when we wonder about the example, it becomes some kind of 0, 0, 1. Sometimes it becomes more 0, 1, 0, 1, 0, 0, or sometimes it becomes 0, 1, 0. When we rotate about x-axis, when it rotate about y-axis, and when it rotate about z-axis. And this becomes the direction of the S-frame based on the S-frame. So, and V can be calculated using this equation. And in the prismatic joint, omega I becomes 0, and V becomes the direction of translation. So also, this one becomes some kind of 0, 0, 1, or 0, 1, 0, or 0, 1, 0, 0. Some kind of this formula. So let's think about 3R robot. This one is example 4, 1, 2. There is S frame here, and this one is 0 position. In the 0 position, the end effector position is here. So M becomes X3 direction is here, Y3 direction is here, Z3 direction is here. So we can make the M matrix using the direction of this joint, this plane. So x3 equal minus z-axis. So it becomes 0, 0, minus 1. And y3 is equal to y0 axis. So it becomes 0, 1, 0, 1, 0. And z3 is equal to the x0. So it becomes 1, 0, 0, like this. And the position of this point becomes to the x-axis L1 and minus z-axis L2. So minus L2. So this one is M. And then just to be find the omega. So theta 1 is rotating about z-axis. So it becomes 0, 0, 1. And theta 2 is rotating about minus y0 axis. So it becomes 0, 0, minus 1, 0. And Z3 is rotating about x0. So it becomes 1, 0, 0. And V1, V2, V3 can be calculated. V1 equal minus Q omega V. And the position of Q1, because 0 axis is here, Q1 is 0, 0, 0. And Q2 is equal to the L1, 0, 0. And Q3 equal L1, 0, minus L2. So, no. Because the Q position can be any point in the square axis. So this square axis can be, the Q can be here. So we can simply write 0, 0, minus L2. So using this one, it becomes V2, V3, V1 become like this. So do the calculation, do your own, this one. So we can calculate the SE3 form S1, S2, S3. Or we can express the tabular form with like this. Using this information and this information, we can make the forward kinetics using this equation. So there is library, modern robotics library. When we know the skew axis and the M matrix, it can easily calculate this T matrix. So you can do that. There is another examples, and about that, let's make some break time, and I will continue.